Hello, here we have it's section 3.5. It's about rational functions and their asymptotes. Let's define a rational function. We did work on polynomials until now in this chapter. What is a rational function? A rational function is a function which looks like a fraction where numerator is a polynomial function and denominator is also a polynomial function, provided q of x, which is denominator, which is not equal to 0. So an example of this would be, say f of x is x plus 3 divided by x plus 4. If you notice, numerator is a polynomial with degree 1. Denominator is a polynomial with degree 1. This is an example of rational functions provided x plus 4 is not equal to 0. Let's take another example. Say we have f of x is equal to x square minus 2 divided by x plus 3. This is another example of a rational function. So a rational function is a function which looks like a fraction where numerator is a polynomial and denominator is also a polynomial. So now let's learn about basic notations. When I write x approaches to c positive on the number line, that means that if there is some c value, x is approaching c from right, but it will never be equal to c. So that is meaning x is getting very small slowly and it is approaching to c value from right side. Okay, then we have x approaching to c negative. This negative on top means that x is approaching to c from left side but will never be equal to c. So on number line, if there is a value c, x approaches to c from left side, it gets very close to c but never actually turns into c. Then we have x approaches to infinity. X approaches to infinity means x increases without any bound. So we have on number line, if the middle is 0, if we keep on going towards right, eventually x approaches to infinity. So when x approaches to infinity, you need to see it as the most right possible corner of the number line, because x is increasing infinitely without bound. If x is approaching to negative infinity, means that is the most left corner of your number line of your x-axis, as that means x decreases without bound. So let's see if you understand that notation. The graph of this function f of x is equal to x minus 1 divided by x minus 3 is given. Now this is the graph of the function x minus 1 divided by x minus 3. Complete these statements. As x approaches to infinity, what happens to the function? The function is this blue curve. Okay, so the y value is the function, right? So what happens to the y value as x is approaching to infinity? Now understand, x approaches to infinity means x keeps on increasing without bound. As this is going towards infinity, what is happening to the y function? It is approaching a value which is as close to this horizontal line. What is this horizontal line value? 1. So that means f of x is approaching 1 from above. It's coming from above and slowly it's approaching that value which is at 1. Okay, so f of x is approaching 1 from above. What happens when x is approaching to negative infinity? When x is approaching to negative infinity is on the left side. The function is this blue curve. Slowly it keeps on going towards y value which is at 1. So f is approaching still 1 but from below. What happens when x is approaching to 3 positive? What does positive means? X is approaching to 3 from right side. So x value at 3, where is x value? 3, which is here. So x is approaching to 3 from right side. That is what it means. Okay. So as x is approaching to that number 3 from right side, the curve is going towards infinity. This y value, where is it going? Towards infinity. So f of x is approaching to infinity. It starts to increase without any bounds. What happens when x approaches to 3 negative? What does that mean? X is approaching to 3 from left side. When the graph, then the x is approaching to 3 from left side, what happens to the curve? The curve starts going down without any bound. That means it is approaching to negative infinity. So that is the notation. Okay. Now let's understand what is the asymptote. Let's start with vertical asymptote. A line x is equal to c, which is a vertical line, is called vertical asymptote of the graph if fx approaches to infinity or negative infinity, x approaches to c. So when x is approaching to that, in this case it is approaching from left, x is approaching to c, then the graph is approaching to infinity. Or when x is approaching to c, the graph is approaching to negative infinity. So these are two examples of your vertical asymptote. Now x is equal to c, that line is a vertical asymptote. Similarly, if x is approaching to c from right side and the function, the graph approaches to infinity, still this is a vertical asymptote. Or the x is approaching to c from the right side and the graph approaches to negative infinity, then also this is your vertical asymptote. So what is the definition? The vertical line x is equal to c is called vertical asymptote of the graph if the function approaches to infinity or negative infinity as x approaches to c from the either side. Now let's understand how can we actually find vertical asymptote. Let's consider a rational function f, which is defined by f of x is equal to px by qx, meaning numerator is a polynomial and denominator is also polynomial, where px and qx have no common factors. So if they have any common factors, you have to cancel them out. If c is a real zero of qx, what is qx? Qx is your denominator. If c is the real zeros of denominator, then x is equal to c. That vertical line is the vertical asymptote of the graph f. So let's see an example. The first step is to find the denominator. Denominator in this case is x minus 3. You plug it equal to 0 to find its zeros. So x is equal to 3 is the 0 of 3 is 0 of denominator, which is x minus 3. That means x is equal to 3 is your vertical asymptote. Let's try another example. G of x is given to be x minus 4 divided by 3x square plus 5x minus 2. Let's first do a step to factorize the denominator. When I'm factorizing the denominator, it is 3x minus 1 times x plus 2. Let's find the zeros of denominator, which is 3x minus 1 times x plus 2. To find zeros, you have to write it equal to 0. X would be 1 by 3 or x would be negative 2. So there are two zeros, and if you write them as equation, x is equal to 1/3 and x is equal to negative 2. These two are your vertical asymptotes of the given graph. Let's look at that desmos.com. I plotted this graph x minus 4 divided by 3x square plus 5x minus 2. So this is the graph, okay. And then I plotted x is equal to 1/3 line. This is x is equal to, this equation blue line is x is equal to 1/3. You see how as x is approaching to that point from right, the graph is approaching to negative infinity. So this is your asymptote. Similarly, x is approaching to 1 by 3 from left, the graph is approaching to infinity. So the blue line is a vertical asymptote. visually also, right? And similarly, x is equal to -2 is also, this purple line is x is equal to -2. This is also looking like a vertical asymptote visually, but we found it algebraically. Let's try one more. We have this function k of x is equal to 4x square divided by x square plus 4. We want to find vertical asymptote. For that, you need to find zeros of denominator. What is denominator? In this case, it is x square plus 4. X square plus 4 equal to 0, which is not possible for any real number. For any real x. Why? Because this will give you x square is equal to -4, which is not possible, right? So there is no vertical asymptote for this particular example.